when the sky became breathable. For most of Earth's history, breathing would have been deadly. The air burned lungs that did not yet exist. And then, slowly, the sky began to change. Life did not inherit a welcoming atmosphere. Early Earth's air was thick with carbon dioxide, methane, and toxic gases released from deep within the planet. Oxygen, the gas that now defines survival for complex life, was almost non-existent. This matters because the transformation of the sky was not a side effect of life. It was a turning point that reshaped the planet itself. The atmosphere we depend on today was built by organisms that had no awareness of what they were creating, and the process nearly destroyed the world they inhabited. The earliest living systems thrived without oxygen, drawing energy from chemical reactions in water and rock. For millions of years, they existed quietly, altering their environments in ways too subtle to notice. But among them were organisms that discovered a powerful trick, using sunlight to split water and store energy. In doing so, they released oxygen as waste. This metabolic innovation was among the most consequential events in Earth's history, though it unfolded so slowly that its effects remained invisible for an immense stretch of time. At first, that oxygen did not rise into the air. It reacted instantly with iron in the oceans and rocks on land, binding itself into minerals and sinking out of sight. The planet absorbed the change without showing it. Life was producing oxygen, but Earth was hiding it. The oceans themselves served as a vast buffer, soaking up oxygen as fast as it was released and locking it away in chemical bonds that removed it from circulation. Over time, those sinks filled, iron became saturated, rocks oxidized. The planet's ability to absorb oxygen weakened, and the gas began accumulating where it never had before. Slowly, imperceptibly, oxygen leaked into the atmosphere. This was not a gentle upgrade. Oxygen was toxic to most existing life, triggering one of the earliest mass extinctions in Earth's history. Entire ecosystems collapsed as the sky itself turned hostile to what had once dominated the planet. But destruction was only half the story, because as the air changed, new possibilities began to emerge. The sky was becoming breathable. As oxygen spread through the atmosphere, Earth entered a period of profound instability. Life that had thrived in an oxygen-free world suddenly faced an invisible poison. Metabolic pathways that once powered entire ecosystems became deadly liabilities, and vast populations vanished as environments transformed faster than adaptation could follow. The planet experienced one of its first true biological crises, a catastrophe driven not by geology or impact, but by life itself turning against its own foundations. Yet oxygen did more than destroy. In the upper atmosphere, it began forming ozone, creating a protective layer that filtered the sun's most damaging radiation. For the first time, the surface was shielded from relentless ultraviolet light, allowing life to explore environments previously off-limits. What had once been lethal exposure slowly became survivable space. This invisible shield would prove essential for every form of complex life that followed, opening the land surface as a habitat for the first time. The chemistry of the planet shifted everywhere at once. Oxygen reacted with gases in the air, reducing methane and cooling the climate. The sky cleared. Sunlight reached the surface more efficiently. Oceans changed color as iron oxidized and settled, leaving behind clearer waters that altered light penetration and energy flow. Life responded unevenly. Some organisms retreated into oxygen-poor refuges, surviving in niches that preserved ancient conditions. Others adapted, learning to harness oxygen's power to release far more energy than anaerobic processes ever could. This innovation unlocked complexity, enabling larger, more dynamic forms to exist. The ability to use oxygen for metabolism represented a fundamental leap in energy efficiency, one that would ultimately make possible every animal, every plant, and every ecosystem that followed. The planet itself adapted alongside life. Oxygen-driven weathering accelerated the breakdown of rocks, drawing carbon from the atmosphere and stabilizing climate over long timescales. Earth systems adjusted, reinforcing the new atmospheric state instead of reversing it. What began as pollution became infrastructure. Oxygen reshaped the sky, the surface, and the future of life itself. The transformation was irreversible. With oxygen now woven into the planet's systems, Earth entered a long and uncertain transition toward complexity. The new atmosphere did not immediately create familiar life, but rewrote the limits of what was possible. Energy became more accessible, allowing organisms to grow larger, develop internal structures, and interact with their environments in more dynamic ways. The oceans responded first. Oxygen penetrated surface waters, creating layered environments where different forms of life specialized at different depths. This separation reduced competition and encouraged diversification. Food webs became more intricate, linking organisms into systems that could persist even when individual species failed. Life was no longer isolated reactions. It was becoming networks. The interdependence of these networks meant that the success of one species increasingly depended on the success of others, weaving a biological fabric that grew stronger with every new connection. On land, oxygen-driven weathering transformed barren rock into soil-like material capable of retaining nutrients and water. While the surface remained mostly lifeless, the groundwork was being laid. Earth was preparing environments that could eventually support life beyond the oceans, long before anything was ready to make that move. This buildup came with tension. Higher oxygen levels increased the risk of runaway reactions, including massive fires once planned to eventually appear. The planet walked a narrow line between enrichment and instability. Balance was not guaranteed. It had to be maintained continuously through feedback between life, rock, water, and air. The emotional peak of this chapter lies in that uncertainty. Oxygen opened doors, but it also raised stakes. Earth had transformed its sky, but now it had to live with the consequences of that change. The planet was no longer defined only by geology. Biology had become a planetary force. And with that shift, Earth entered a new era, one where life and planet would evolve together, inseparably linked. The climax of Earth's atmospheric transformation was not the rise of oxygen alone, but the partnership that followed. Life and planet became locked in a feedback loop, each shaping the other in ways that could no longer be separated. The sky was no longer just a byproduct of geology. It had become a living system, maintained and modified by the very organisms it sheltered. As oxygen stabilized, complex life slowly gained ground. Metabolism became more efficient, structures more elaborate, and interactions more intricate. The planet supported organisms capable of altering landscapes, cycling nutrients, and influencing climate. Earth had crossed from microbial world into something with depth, resilience, and momentum. The resolution of this change lies in how familiar it feels today. Breathing seems effortless, invisible, and guaranteed. But the air we rely on is a result of billions of years of conflict, adaptation, and survival. It exists because life once changed the planet in a way that nearly destroyed itself, and then learned to endure the consequences. This history carries a quiet warning. Earth's systems can transform rapidly when pushed beyond balance. They can recover, but recovery comes with cost and uncertainty. The breathable sky is not a constant. It is an achievement, maintained through fragile equilibrium. When the sky became breathable, Earth became alive in a new way. The planet and its life were no longer separate stories. They became one. Subscribe to join the journey. When the